Okay, Bismillahirrahmanirrahim. Assalamu alaikum. Right, so we are live on YouTube, live streaming basically. Right, so today we are going to discuss something very, very important, which is actually measures of morbidity. And morbidity is basically defined as a disease or injury in terms of public health and epidemiology. The other term we use is mortality, which means death or the fatality. So today we are going to discuss only about measures of morbidity. So when we talk about the measures of morbidity, it is very, very important to understand and to know how to calculate the measures of morbidity, because this is what helps us to plan out all the curative services as well as the preventive services. So if we don't have measures of morbidity, we cannot really plan any sort of preventive or any sort of treatment or curative services for our population or the community for which we are working actually. Right, so there are different types of morbidity. First one is known as incidence. Now it is very, very important terminology when it comes to measures of morbidity. So first of all, you need to understand what is incidence. Now when we talk about the term incidence, it actually refers to the risk of disease in a population or in a community. So say for example, these days everyone is talking about coronavirus pandemic. So say for example, if we want to calculate the risk of coronavirus in a particular community or a population, then what can we calculate, or what should we calculate rather, is incidence. So how do you basically calculate the incidence? So it's very, very simple. So first of all, what you need is a denominator. So what is a denominator in terms of incidence? It is basically your population at risk, not the whole population, not the complete population which you are studying, which you are surveying, which you are researching, but only the population which is at risk for that particular disease. We are going to take that particular population in the denominator while we are trying to calculate the incidence. So say for example, if we talk about the breast cancer, we know that men are not at risk of developing breast cancer. So if we go to a certain community and we are interested in finding out the incidence of that particular community, then what we should do is we should take the population of only women in the denominator. Why? Because it is only the women who are at risk of developing breast cancer, not the men. So again, please understand this: whenever we are going to calculate incidence for a particular disease, we are going to take the population at risk in the denominator. Right, now what about the numerator? When we talk about the numerator, it should contain the number of new cases of that particular disease during a specified time interval in that particular community. Right, so let me repeat it. What would the numerator consist of? It would consist of the new cases of that particular disease which we are studying, which we are researching in that particular population during a specified period of time. Okay, and then we have to multiply this with a particular number that is an arbitrary figure. It could be 1000, it could be 10,000, it could be 1 lakh, it could be 10 lakhs, it could be a crore even. So whatever number is appropriate, we would be basically multiplying with that particular number. Now how do we decide on that number? I'll come to that later on. Okay, now let's take an example and try to understand this in this particular term more clearly. Okay, so say for example, we go to a community and there are, let's say, 500 women in that particular community. Right, it's a small village for your easy understanding. And what we do is we are interested in finding out the incidence of breast cancer in that particular community. Right, so when we survey the village, we come to know that the total women in that particular village is 500. So 500 becomes our denominator. right? If you remember, I mentioned you that in the denominator we only take the population at risk, not the whole population, because we are calculating the incidence, we are calculating the risk of that particular disease, right? Now, so say for example, we take 500 as the denominator. Now for breast cancer, what we generally do is mammography for the diagnosis of the breast cancer. So let's say we survey that uh, whole number of 500 women, and we conduct the mammography of each woman, and we come to know that 20 out of those 500 women, they have got this breast cancer. So our numerator would be 20. Why 20? Because this is the number of new cases which we have got for breast cancer. So what we can simply do is we can simply divide 20 by 500. 20 is the number of new cases of breast cancer, and 500 is the population at risk in that particular village. Now 20 divided by 500 gives us 0.04, right? So we can simply write this 0.04 with us. Now remember, if I told you that we have to multiply this with an arbitrary figure, so this number could be 100, this number could be 1000, this number could be 10,000, this number could be 100,000, depending on what we are researching basically, right? So say for example, I decide a figure of 1000. So I would simply multiply 0.04 by 1000 and I get 40, right? So what I can say is that the incidence of breast cancer in this particular village among women is 40 per 1000, right? It is extremely important to mention the number with which we multiplied whenever we are quoting the incidence. If we don't mention that number, then incidence is meaningless, it has no use whatsoever. So you cannot just say that the incidence of breast cancer in this village is 40. You have to tell that it is 40 per 1000 or 40 per 1 lakh or 40 per 10 lakhs or whatever it is, right? So this is very important for you to understand, that never ever forget to mention the particular number with which you have multiplied. So how do you need to interpret that? So say for example, in our particular case, we multiplied it with 1000. So while interpreting, we would simply say that the incidence of breast cancer in this particular village is basically 40 per 1000, right? Now taking the same example, but this time we would multiply with a different number, right? So say for example, I have gone to the same village again. I have taken the same 500 women at risk as my denominator. I have again found out that there are 20 new cases of breast cancer. So 20 divided by 500 again gives us 0.04. This time I want to multiply this number with 10,000. So 0.04 multiplied by 10,000, that gives us 400, right? But now what is important to understand here is that we would say the incidence of breast cancer in this village is 100 per 10,000. If you don't say per 10,000, then the incidence becomes wrong, that becomes meaningless, because we have got the same figures, 20 new cases and 500 at risk population. So you must have to mention whatever number you have multiplied it with in the form of per xyz abc, right? So 400 per 10,000 or 40 per 1000 gives you the exact same meaning. 400 per 10,000 or 40 per 1000 is absolutely the same, right? So hopefully you have understood how do we calculate the incidence. So as I've already mentioned to you, the formula for incidence goes like this. Incidence, for example, we are interested in finding incidence per 1000, so we would simply say incidence per 1000 equals to number of new cases of a disease occurring in a population during a specified period of time. let me repeat it. Incidence per 1000 equals to number of new cases of a disease occurring in the population during a specified period of time divided by number of persons who are at risk of developing that disease during that period of time multiplied by 1000. Because we have used incidence per 1000, that is why we have put 1000 in the formula. If you would have said incidence per 10,000, then you would have multiplied it with 10,000. If you would have put 100,000 incidence per 100,000, then you would have multiplied it with 100,000. So the choice of figure is absolutely yours. It actually depends on the total population of that particular area or community where you are conducting your research. So say, for example, if we are conducting a research on a city level, so we could have multiplied it with, maybe 10 lakh or a million, which is, or maybe 1 lakh. If we are conducting this research on a national level, so we could have probably multiplied it with 1 crore, or maybe yes, 1 crore would be fine. If we are conducting a research in a small district where the population is maybe 5-6 lakhs, so we could simply multiply it with 1 lakh, right? So this is how you actually decide your figure. You can actually multiply with any figure, but remember always to make figure, otherwise your incidence would be absolutely meaningless, right? So I do hope that you are clear with this. Now, what you do need to understand is that, as I have already mentioned, incidence is a measure of risk of disease in a particular community or in a particular population. So it is basically a transition of a person from a non-diseased to a diseased state, right? Because we are in the numerator, what are we taking? In the numerator, we are only taking the number of new cases. So what that means is we are only interested in those particular cases who have been newly diagnosed with the disease. We are not interested with the old cases. That is why it is called to be the risk of that particular population, because in simple language, risk means chance, or maybe probability. All the probabilities are a very specific term which is used in public health and biostatistics, but for the sake of understanding, so risk is a chance of getting that particular disease, right? Okay. Second thing, what you do need to make note of is that the denominator of an incidence always represents those people who can become a part of the numerator at any time, right? So when we are going to calculate the incidence, what you need to remember is whoever you have included in your denominator must have a potential to become part of that numerator at any given time while you are conducting your research, right? So what do I mean by saying this? This means that, say for example, if we are taking women in the denominator, then any of the women could become a part of that numerator by developing breast cancer at any given time, right? So this is something you should always remember. Now, moving forward, a very important issue with the denominator when we are calculating incidence is the issue of time. And on the basis of time frame, basically, what we do is, okay, someone is asking, Fiz Khan is asking, is there any difference between risk and incidence? No, incidence basically measures calculating incidence. So you can simply say that incidence is meant to calculate the risk of a particular disease. Okay, someone is saying I'm late. Not a problem. The recording of this live streaming will be available on the channel after once this live stream is over. Right. Okay. Right. So I was telling you that the denominator of the incidence, that is very much dependent on the time frame, and on the basis of that we basically divide incidence into two types, right? One is called cumulative incidence and the other one is called incidence density. right? So what I have told you is that on the basis of the time frame in the denominator, we divide incidence into two types. One is called cumulative incidence and the other one is called incidence density. Now, coming to the cumulative incidence, this is quite straightforward. So as the name indicates, cumulative means something in which which is there as a whole, in which we add um, all the available factors. So say, for example, when we talk about cumulative incidence, what that means is that let's assume there are 500 at-risk people in a certain population. And if we are interested in finding the incidence of a particular disease for 1 month, then if we have been able to follow all those 500 people at risk for the complete 1 month, then that means that we can easily calculate the cumulative incidence. So if we are able to follow all the people at risk in a particular population for the complete specified time, then we can calculate what cumulative incidence. Let me repeat it. Say, for example, we have gone to a certain community where there are 500 people at risk for a development of a particular disease. And we want to calculate the incidence of that disease during a time period of 1 month. We always predetermine the time period, right? Now, if we can follow those 500 people for that complete 1 month, we can calculate the cumulative incidence of that particular disease. So in that case, basically what happens is that we are easily able to identify the numerator, which is the number of new cases. Let's say it is 10 or 5 or 15 or whatever. And then in the denominator, we can simply take the um, number of persons at risk, right? And then in the same way, we can multiply it with either with 100 or 1000, 10,000 or 1 lakh or 10 lakhs, whatever. As I have already told you, that was what basically uh, cumulative incidence is all about, right? Now, the problem arises when we cannot follow all the people, all the at-risk people in a particular community for that specified time interval. And this is very, very common because when we talk about the communities, we are normally dealing with thousands and millions of people. So in that particular case, it becomes almost impossible that we are able to follow each and every person at risk for the complete time period, right? Why does that happen? That happens because, say, for example, one person has moved out of that community, so we have lost contact with that. One person has moved out of the country, again we have lost contact with that person. One person has died of another disease or maybe in a road traffic crash, right? So again that is lost. One person has developed the disease of interest. So say, for example, if you are interested in finding out the incidence of breast cancer, let's say 5 persons develop breast cancer. So now they are no more a part of the denominator. Obviously, they have become the new cases. So they straight away go to the numerator. Now they are no more the denominator, right? You're getting my point. So there are two ways in which you can basically lose the follow-up. One, if you lose the contact with that particular person because of one reason or the other, he has died or has moved to another city or country, whatever. Number two, if the particular person has developed the disease of interest, so even in that case, that particular person would go to the numerator now and would no more be the part of the denominator, right? Now when this happens, definitely we have not followed all the people at risk for the complete time interval, right? So in that case, what we have to calculate is not the cumulative incidence, but it is the incidence density. That is the second type of incidence, right? So up till now we have studied two types of incidence. First one was cumulative incidence, um, when you can follow all the people in a particular community for the complete specified time interval. That is cumulative incidence. And number two, incidence density. When you cannot follow all the people in a specific community for the complete specified time interval, then you are only left with the option of calculating incidence density, which is more practical. Why? Because I have already mentioned to you, when we work in the field, when we work with the community, uh, basically loss to follow up is extremely common, because either we lose the contact with the person, or the person develops the disease of interest. Right, so this you have to remember. Now, calculating cumulative incidence, we have already done that. Calculating incidence density is a bit technical. um, for the incidence density, the numerator is calculated in the same way, because it is the number of new cases of the disease. That is exactly the same like we have discussed for um, the cumulative incidence. But when it comes to denominator, the it is different compared to the cumulative incidence. Now, how do we differentiate between that? In terms of incidence density, the numerator remains the same. So if you want to write, you can simply say incidence per 1000, incidence per 1000 equals to equals to number of new cases of a disease, number of new cases of a disease occurring in the population, occurring in the population during a specified period of time, during a specified period of time. This is exactly the same as in case of um, cumulative incidence. Now, divided by, denominator is different. Divided by, in case of incidence density, we divide it by total person time. Total person time. Now, what is this? I am going to explain it in detail now. So let me repeat the formula for calculating incidence density. Incidence rate per 1000, or whatever figure you decide, equals to number of new cases of a disease occurring in a population during a specified period of time, divided by total person time multiplied by 1000, or whatever figure you want to. Now, what is total person time? Just write it and then I'll explain it to you. The sum of the time periods. What is total person time? The sum of the time periods, the sum of the time periods of observation, the sum of the time periods of observation of each person who has been observed, of each person who has been observed for all or part of the entire time period, for all or part of the entire time period. Right, so this is total person time. Now let me explain it to you. So say for example, we have got 5 persons at risk. How many? 5. And our study duration, right? So say for example, we are able to follow the first person for 2 months, right? Second person for 4 months, third person for 3 months, fourth person for 2 months, and fifth person for all 5 months, right? So now you can clearly see that we have not been able to follow all the 5 persons for the complete 5 months, right? We followed first person, let me repeat it. We followed first person for 2 months, second person for 4 months, third person for 3 months, fourth person for again only 2 months, and fifth person for 5 months, right? So how you would calculate the total person time? For the first person, we followed only for 2 months, so 1 multiplied by 2, that is 2. For the second person, we followed for 4 months, so 2 multiplied by 4, that is 8. The third person we followed for 3 months, so 3 multiplied by 3 is 9. The fourth person we followed for again only 2 months, 4 multiplied by 2 is again 8. And last, the fifth person followed for complete 5 months, so that is 5 into 5 is 25. So now we have to add all these because it is total person time. So we have to add 2 plus 8 plus 9 plus 8 plus 25. So this should come out to be as 52, if I'm not wrong. So we can simply say that there are 52 person months. Because we have taken the example of months, so we can simply say person months. It is person time, so right, it could be person years, person months, person weeks, person days, although it is unusual, but for the sake of understanding you can also say person hours, right? Let me repeat the example so that you are absolutely clear. We are going to calculate the incidence density of a particular disease in a population where there are only 5% at risk of that particular disease. Our time frame is 5 months. So we have followed first person for 2 months, second for 4 months, third for 3 months, fourth for 2 months again, and fifth person for 5 months. Now we can simply multiply person number one because we followed him for 2 months. So 1 multiplied by 2 is 2. Second person followed for 4 months, 2 into 4 is 8. Third person we followed for 3 months, so 3 into 3 is 9. Fourth person followed for 2 months, so 4 into 2 is 8. Fifth person we followed for 5 months, so 5 into 5 is 25. So adding 2 plus 8 plus 9 plus 8 plus 25 gives us 52. 52 person months, you can simply say 52 person months, right? Say for example, out of those 5 uh, persons who were at risk, that is, now our denominator has become what? 52. How much? 52. Because 52 is the person time. We are calculating not the cumulative incidence, but we are calculating incidence density. So in this case, our denominator becomes 52. Now say for example, 2 persons develop the disease during this time. So our numerator becomes 2 because 2 is the number of new cases. So 2 divided by 52, this becomes 0.038. 2 divided by 52. Why 2? Because 2 is the number of new cases. In numerator, we always take the number of new cases. Then why 52? 52 is the person time, to be specific, person months. So 2 divided by 52 gives us 0.038. Now we have to multiply this with a particular number. So let's say we take 1000. So 0.038 multiplied by 1000 gives us 38.46 per 1000. 38.46 per 1000. Please don't forget to mention whatever figure you have multiplied it with. 38 per 1000, right? So this is exactly how you calculate the incidence density for a particular disease, right? Okay, so if I can show you, I'm not sure if there is an option of screen sharing here. If I can share my screen, I would like to show you another very good example so that you are Absolutely clear. Okay, just give me a minute. I have to find out if there is an option of sharing screen. Must have, I believe. Okay. I am not able to find that. Let me check if I can. Just a second. Okay. No, I think it does not allow me. Um, okay, I think I don't have that particular privilege. Okay, right. Doesn't matter. It's not a problem. Okay. As of now, I do hope that now you can very easily calculate the cumulative incidence as well as incidence density for a particular disease, right? Um, okay, now there is another measure of morbidity which is called as attack rate, right? Okay, so attack rate, what happens is that sometimes the denominator, whenever we are calculating any measure of morbidity, the denominator is specifically specified implicitly rather than explicitly, right? Implicitly means something which is said, which is stated indirectly, and explicitly means something which is said or which is stated directly. So sometimes when we are calculating the measures of morbidity, what happens that the denominator or the time frame in the denominator is basically implicitly stated rather than explicitly. What that means is that the denominator is not clearly, the time in the denominator is not clearly stated, or the time in the denominator cannot be clearly stated. So right. So say for example, I'll explain it to you as well. So say for we are going to calculate the food specific attack rate, which we normally do whenever we talk about attack rate. Even as dietitians or nutritionists, you should be able to calculate the food specific attack rate. So say for example, there are a few people who have gone out to attend a particular party, and they have eaten some salad over there, right? And that salad was contaminated, right? So say for example, there were 99 people, just to give you a hypothetical example, there were 99 people who ate that particular contaminated salad, and out of those 99 people, 30 developed food poisoning, right? How many? 30 developed food poisoning out of those 99 who ate that particular salad in a party. So how can we calculate the food specific attack rate? It is very, very simple. All you have to do is you have to divide 30 by 99, right? 30 by 99 gives you 0.30. It's as simple as that. So what you have to do is you have to divide 30, which is the number of people who have consumed food salad and who have become ill, who have developed food poisoning. So that number is 30. And how many total people ate that food salad? That number was 99. So you just divide 30 by 99 to get 0.30, right? So this is how you simply calculate the food specific attack rate. Now what is the formula? How can we put it in terms of a formula? You can simply write it: food specific attack rate equals to number of people number of people exposed, to a suspect food, number of people exposed to a suspect food who became ill, number of people exposed to a suspect food who became ill, divided by number of people who were exposed, divided by number of people who were exposed to that food, right? So it's very simple. In the denominator, you have to take all those persons who ate a particular food. Let's say there were 200 people. In the numerator, you have to take those people who ate that food and became ill. So let's say out of 200, 25 out of those 200 who basically ate a particular food, 25 became ill. So you can simply divide 25 by 200 and it gives you 0.12, right? So this is how you can simply calculate food specific attack rate. Now remember, in the start of attack rate, I said that in case of attack rate, the time in the denominator is actually implicitly stated rather than explicitly. That means indirectly, it cannot be stated in clear terms. Now, what is the reason for that? What do you think? The reason for that is when we talk about foodborne outbreaks, the disease sometimes does not develop immediately after consumption of a particular food, right? It takes some time. So you can associate it with the incubation period of a disease. If you have watched my video on what is incubation period, right? So because of that, we cannot be absolutely sure that the cases which are developed, that is because of the consumption of that particular food item or because of something else, right? So that is the reason we say that the time frame in case of food specific attack rate is not explicitly defined. In fact, it is implicitly defined because we are not absolutely clear, we are not absolutely sure, right? Another thing to consider here is that when we talk about attack rate, it is not truly a rate, but it is actually a proportion. Although the name says that it is a rate, but it is not truly a rate. It is a proportion, right? So you have to remember this. Now you might be wondering, isn't this the same as the proportion? No, these are two different terms. Let me explain to you. Now, there is another terminology which we very commonly use in epidemiology and biostatistics, that is called the ratio. The ratio is the expression of one measure relative to another, right? For example, waist to hip ratio. We simply call it as. So we take the measurement of waist, we take the measurement of hip, and we divide these two, and we get a certain number. And ratio, if you recall from your previous knowledge, ratio is always unitless because the unit is the same. So both are cancelled out, right? So this is a ratio. This is a ratio. This is an umbrella term. This is a general term. There are two major types of ratio. One is proportion. One is rate. Let me repeat it. When we talk about the ratio, it is the expression of one measure relative to another. For example, waist to hip ratio. So we took waist measurement, we took hip measurement, we divided both of these, and we got a unitless number, right? Now, when we talk about ratio, there are two types of ratio. One is proportion, one is rate. Now, proportion is very simple. Proportion is the part of something to the whole of something, right? Part of something to the whole of something. So say, for example, 10 out of 100, it's a proportion. 20 out of 100, it's a proportion. 30 out of 100, it is a proportion. 50 out of 100, it is a proportion. Whatever is that, right? When we talk about the rate is also a type of ratio, but it has another dimension in the denominator, and that another dimension generally is the time frame. So that is the difference between rate and proportion. Let me repeat it. Rate is also a type of ratio, but in case of rate, there is another dimension, and that another dimension is generally the time frame in the denominator. always in the denominator, right? So what did we say? We said that attack rate is not truly a rate, but it is actually a proportion. Why we are saying this? Because if it would have been a true rate, there would have been a clear cut explicit definition of time interval in attack rate. But since we are not really sure of the time interval, time frame in case of attack rate or food specific attack rate, so we call it, or we categorize it more as a proportion rather than being truly a rate, right? So this is the difference. So if anyone asks you the difference between rate and proportion, you just have to say both are types of ratio, but proportion is the part of something to the whole of something. It does not consider, it does not take into account the time frame. While the rate, when we talk about the rate, in rate, there is always another dimension in the denominator, and that other dimension in the denominator is generally 99% of the time, that is time frame, that is time interval, right? So that is rate. So that is why we call that attack rate, although the terminology is attack rate, it is not attack proportion, attack rate, but it is actually a proportion, not really a rate. It cannot be categorized as a true rate because it does not specifically or directly define the uh, time frame or the time interval, right? Now the third and the last measure for today is prevalence. And believe me, you would get this question quite often in your interviews or maybe some admission tests for postgraduate degrees or whatever. What is the difference between incidence and prevalence? So this is very, very important to understand. Now we have already discussed incidence in detail, and two types of incidence. One was cumulative incidence, other was incidence density. And incidence always talks about risk, incidence always talks about the number of new cases, remember. Now what about the prevalence? So prevalence is different compared to incidence. Prevalence is a measure of disease burden in a community. Incidence is a measure of risk of a disease in a community. Prevalence is a measure of disease burden in a community. Let me repeat it. Incidence is a measure of risk of a disease in a community. Prevalence is a measure of disease burden in a community, right? Why? This is because incidence only considers new cases of a disease. Remember the numerator. Incidence only considers the new cases of a disease. On the other hand, prevalence takes into account both the new cases and the old cases of a disease. So that is why prevalence is the total disease burden in a community. Incidence only tells you about the risk of a disease because it only considers, or it only takes into account the new cases of a disease, while prevalence tells you the disease burden in a community. Why? Because it takes into account both the new cases and the old cases of a disease in a particular community, right? So for the sake of writing the formula, you can simply say prevalence per 1000, prevalence per 1000 equals to number of cases, within bracket you can write new plus old. Number of cases within bracket, you should write new plus old so that you don't forget. Number of cases, new plus old, of a disease, present in the population, present in the population at a specific time, present in a population at a specific time, divided by, here is another major difference, divided by number of persons in the population, number of persons in the population at that specified time multiplied by 1000. Multiplied by 1000. So now there are three major differences between incidence and prevalence. Number one, incidence is a measure of risk. Prevalence is a measure of disease burden. This is the first major difference. Number two, incidence only takes new cases in the numerator. Prevalence takes new plus old cases in the numerator. Number three, incidence only takes at-risk population in the denominator. Prevalence takes the whole population in the denominator. Right? Going back to the same example of that breast cancer in a village. Now, this time, okay, Muhammad Hasnan is asking, sir, we said incidence is also a rate, but in the formula, we don't have any time interval. No, there is time interval. If you look at the formula, what is the formula of incidence? We say number of new cases of a disease occurring in the population during a specified period of time divided by number of persons who are at risk of developing the disease during that period of time. So we have clearly defined the time period, right? So that is why we say that incidence is also a rate, right? Always remember, whenever there is a rate, there is time, or there is time, that means it's a rate, right? Specifically when we are talking about cumulative incidence or incidence density, right? Okay, coming back to, hope you are clear. If you are not clear, please ask again. Okay, coming back to prevalence, taking the same example of breast cancer in a village. Now we are going to the same village. Now we are interested in finding out the prevalence of breast cancer in that particular village, right? Earlier we found out incidence for breast cancer in that village. What was that? Probably 40 per 1000, whatever that was. Now, say for example, we are interested in finding out the prevalence. What do we need to calculate prevalence in the numerator? We need new cases and old cases, right? For example, we went to the village, we took all the women for the mammography. Only women, because I'm saying only women. Ideally, I should have said all the whole population, but I'm saying only women because it is breast cancer. So males are not generally at risk of developing breast cancer, right? Okay, so we took all the women for mammography. We found 20 new cases, right? So in the numerator, we can write 20. Now this is the new cases. What about the old cases who are already diagnosed cases of breast cancer in that population? Let's say there were 10 old cases. So the numerator becomes 20 plus 10 equals to 30. Let me repeat it. We have gone to the same village again with a total population of 1000. There were 500 women in that. There we got 20 new cases of breast cancer, and on taking history, we found out that there were 10 old cases of breast cancer. So 20 plus 10, 20 new cases, 10 old cases. This is the numerator, which becomes 30. Now in the denominator, what we have said, what would be the denominator of prevalence? That is number of persons in the population at that specified time. How many people are there in our case? 1000, right? So we can simply say 30 divided by 1000. So let's multiply it with 10,000. Let's say I'm calculating prevalence per 10,000, right? Clear? So what we can do is we can simply divide 30 by 1000, which gives us 0.03, and then we have to multiply it with 10,000, which gives us 300. Similar to incidence, you must have to mention per whatever. So again, that whatever figure is arbitrary, that is absolutely your choice, but you must mention that. If you don't mention that, then again the prevalence becomes meaningless. There is no use of, there is no significance of that prevalence which you mention without uh, specifying that particular number, right? So that means we can simply say that the prevalence of breast cancer in that village is 300 per 10,000, right? Prevalence of breast cancer in that particular village is 300 per 10,000. Earlier we had said incidence of breast cancer in that village is blah blah blah, whatever it was. Now we have mentioned how can we interpret prevalence. The prevalence of breast cancer in that particular village is 300 per 10,000. Now this prevalence is showing the disease burden out of the total population. What is the burden of the disease? Whether males or females doesn't matter. That disease is definitely in that particular population. So that is the burden for the whole population, right? While in terms of incidence, we are only interested in finding out the risk. Who can develop or who just recently became a new case of the disease in case of incidence, right? Okay. Doing the same example, now say for example, I had the numerator of 30 and a denominator of 1000 because there were 1000 persons in the population. Now I simply want to multiply it with 1000. So you can cancel 1000 with 1000, you can simply get 30. Now this 30 is per 1000. So you can either interpret that the prevalence of breast cancer in that village is 30 per 1000, or the prevalence of breast cancer in the village is 300 per 10,000. Both are absolutely the same and both are absolutely correct to say. Even you can multiply it with 100,000, which is 1 lakh. So in that case, what you would get? You would get 3,000. So you can also say the prevalence of breast cancer in the village is 3,000 per 1 lakh or 3,000 per 100,000. That's it. All three are conveying the exact same meaning, and it is absolutely fine to use first or second or third interpretation, whatever you like, whatever you want to use, right? Let's take another example. We're talking about prevalence, right? Okay. A sample of 100 middle-aged women was followed for 10 years. How many? 100. All subjects entered the study on 1st January of the year and followed for the next 10 years. There was no loss to follow up. During this period, 5 subjects, that means 5 persons, were diagnosed with ovarian cancer, but they all survived to the end of the study, right? So what was the prevalence of ovarian cancer when the study ended? So that simply means how many new cases developed during the study. How many they are saying? 5. 5 becomes the numerator. 5 is the number of new cases. What was the total population which we were studying? How many people were there? How many subjects were there? How many participants were there? 100. So 5 divided by 100, you get 0.05. You can simply multiply it with, say, 1000. So 50 per 1000, or you can multiply it with 10,000. You can say 500 per 10,000. Right? Hopefully it's clear. Now, taking another example. In a survey of 1150 women, that is 1150 women, who gave birth to children in the year 2000, a total of 468 reported taking a multivitamin on daily basis. Calculate the prevalence of multivitamin use in this group. It's very, very simple. What was the total population? How many women were there in the study? 1150. That becomes the denominator. What were the number of new cases? New cases here means number of persons who were using multivitamin. That was 468. So 468 divided by 1150, that gives us 0.40. We can multiply it with 1000. So that is 406 per 1000. Prevalence of multivitamin usage in that group was 406 per 1000 women. Prevalence of multivitamin usage in that group was 406 per 1000. Right now, practically speaking, generally what you learn about the figures of different diseases in Pakistan or any other country, that is generally prevalence. For example, a recent report has stated that in Pakistan, prevalence of diabetes, I've told you already, prevalence of diabetes is 25%. Or, in other words, they say that 1 out of every 4 Pakistanis is adult Pakistanis is diabetic. So what that means is 1 out of every 4 is 25%. So that means 25%. Whenever we say percent, so that means per 100. So that means that they have calculated prevalence in terms of multiplying with 100. So 25 per 100. You can simply interpret. If someone says, what does this mean? 25% Pakistani adults are diabetic. You can simply say that means the prevalence of diabetes among Pakistani adults is 25 per 100. Right? Or you can also say the prevalence of diabetes among Pakistani adults is 250 per 1000. That is absolutely the same. 25 per 100 or 250 per 1000. Both are conveying the exact same message. Both are absolutely fine to use. You can use either of these. But don't forget to mention, I've stated this time and again, don't forget to mention per whatever. Now, prevalence is again of 2 types. Don't worry, this time it is very simple. It is not as complicated as incidence. Right? Prevalence is of 2 types. First is point prevalence and the second is period prevalence. So I have told you that prevalence is of 2 types. First type is point prevalence and the second type is period prevalence. Now, as the term indicates, point prevalence is the prevalence of disease at a certain point in time. Say, for example, yesterday, if I calculated the prevalence of a disease in a community on 13th April 2020, then it was point prevalence because I calculated the prevalence at a specific point. On the other hand, what is period prevalence? Period prevalence means how many people have had the disease at any point during a certain time period. Say, for example, I am interested in calculating the prevalence of diabetes in Islamabad in the year 2001. So I would start from January 1, 2001 to December 31, 2001. So that's a complete time frame. So any person who develops disease, who is the new or the old case of diabetes during those 12 months, that becomes definitely my numerator. And that is called the period prevalence because there is this whole time period involved. On the other hand, in case of point prevalence, there is only one specific point in time, right? So again, this time period is absolutely our choice. We could calculate prevalence for 1 month, we could calculate prevalence for 1 week, we could calculate prevalence for 1 hour even, although it does not make sense. Practically speaking, we can calculate prevalence for 1 year, we can calculate prevalence for 10 years, depending on the type of research we are doing, depending on the type of research we are involved in, right? What you should remember in case of period prevalence is that whoever is there in the numerator had that disease at some time during the specified time period. For example, we calculated prevalence of diabetes for 1 year. Now let's say our numerator is 100, right? So that if the person is there in the numerator, that means the person is either the new case of diabetes or the old case of diabetes. There cannot be a third option. Agreed? What I'm saying is, if we are calculating the prevalence and we have got a numerator of 100, that means that all those 100 persons, they were either new cases of a disease or they were old cases of a disease, right? And that also means, because in the denominator we are taking the whole population, so at some point in time they were a part of the denominator. As soon as a person develops the disease, he or she is immediately moved from the denominator to the numerator, because that becomes the new case, right? So from the total population, he or she jumps to the new or the old case, right? So always remember, the numerator was a part of the denominator at some point in time, right? So this is the difference between point prevalence and period prevalence, right? One more thing, always remember, whenever we are calculating the prevalence, we are not able to determine when was the disease developed, right? Because we are taking both new and the old cases. For example, we are in a community trying to determine the prevalence of breast cancer. So we never know someone developed breast cancer 10 years ago or 20 years ago, right? So that is why we say that prevalence does not calculate risk. It calculates the disease burden in the community. It cannot calculate, it can never ever calculate the risk. If you want to calculate the risk of a disease, you have to calculate the incidence of the disease, right? And they also say that prevalence is just like a snapshot of a population at a point in time. Snapshot means, taking a picture. So specifically in terms of point prevalence, it's a picture of a population, picture of the disease of a population in that time, at that particular time, right? So it's a snapshot of a population. So whenever you see the term snapshot of a population, you should immediately know that they are talking about prevalence. They are not talking about the incidence of a disease, right? Okay, so this is all about the incidence, attack rate, and the prevalence. Now I do hope that you can calculate incidence, you can calculate the prevalence, and you can also calculate the attack rate or the food specific attack rate. Most importantly, you know the difference between incidence and prevalence. We started three major difference. Incidence is a measure of risk, prevalence is a measure of disease burden. Incidence only takes into account the new cases of a disease in the numerator, prevalence takes into account the new as well as the old cases of the disease in the numerator. Incidence only considers population at risk in the denominator, prevalence takes the whole population in the denominator, right? So these are the three major differences. So now I do hope that you know these three differences between incidence and prevalence. Also, you know the two types of incidence. One is cumulative incidence, in which we follow all the at-risk persons during that specific time period for the complete time. And the second one is incidence density, in which we are not able to follow all the persons, all the at-risk persons for the complete time period, right? And there what we calculate is total person time, and I have already explained to you how do you do that. Coming to the prevalence, there are two types. One is point prevalence, at a specific, when we calculate prevalence at a specific point in time, and the other one is period prevalence, when we calculate the prevalence of a disease in a specified time period, right? And thirdly, we also studied the attack rate, which is not truly the rate, but it is more of a proportion. Why? Because it cannot and it does not specifically define the time frame. So that is more of a proportion rather than a rate. And I have also told you the difference between proportion and rate. Proportion is out of something, out of the whole of that thing. um, while rate is also a type of ratio, but it takes into account a third dimension, and the third dimension is generally the time in the denominator. And what is ratio? You can simply say that it is an expression of one measure relative to another, and it is unitless because the units are same in both the cases. um, Lishbar also is asking, sir, then cumulative में short time ही होगा, long time तो नहीं? Uh, while calculating cumulative incidence, yes, that's right. Um, because it is generally, 99% of the time, it is not possible to follow all the persons in a population. It's a very good question, actually. What you can remember, you can understand is, if the population is closed, if the population is a small one, for example, there are 100 people, maybe there are 30 people, maybe there are 50 people. If you have gone to a small office, you are conducting your research there. Maybe you have gone to a small private school where there are 150, 170 small little children, or any other closed population, then chances are quite high that you would be able to follow all those people for the complete specified time frame. Maybe it is 1 month or 2 months, or 2 months or 3 months. But if the population is an open population, for example, you are conducting at a city level, national level, international level, district level, village level, then it is almost, practically speaking, it is almost impossible to calculate the cumulative incidence. You have to calculate the incidence density, because loss to follow up is very, very common. People move out of the places, people move out of the countries, people move to the cities, people move to some other places, people die of some other disease, people die of road traffic crashes, um, people develop the disease under interest, so they become a part of the numerator then. So it is almost impossible to calculate, practically speaking, to calculate um, cumulative incidence. So you have to actually rely on incidence density by calculating the total person time, right? It is not very much possible. Or if you are, like you are saying that in the cumulative incidence time frame is short, well, it really depends on the disease. If the disease of interest develops in 2 years, 3 years, maybe, then we cannot put the time frame as very, very brief, because then that does not make sense. For example, it is said that once a person starts smoking, it takes generally 10 years to develop lung cancer, right? Now, if we are interested in determining the incidence of lung cancer in a population, and we define time period to be as 3 months, so that no person is lost, there is no loss to follow. But do you think that anyone would develop lung cancer in 3 months? Not really. The chances are very, very low, practically speaking. So at the end of the day, we would be getting zero in the numerator. So would it make any sense? Zero divided by something is zero. So does it make any sense? Not really. So it actually depends on the type of disease under consideration. Yes, if the disease is very, very, if the disease develops very, very quickly, then we can define the time period to be very, very brief. For example, 1 week or 2 weeks, and chances would be high that there is no loss to follow, right? So I do hope that I am, sorry, you are clear now regarding all these terms, and now you can calculate incidence or prevalence or attack rate, or specifically while calculating the incidence density, you can calculate the total person time, right? So I think that is enough for today. This lecture would be available on my channel as soon as this live stream is finished, and you can always go back if you have not understood something. You can always go back and you can watch the lecture and take notes or whatever. And if you want to ask me any questions, I am here for 1 2 more minutes. If anyone has any questions, he or she is more than welcome. Otherwise, even later on, you can ask me questions. You have got all my contact details. Right. I think there's no questions. Okay, it's good. These are quite technical terms. These are not very easy to understand. So what I would ask you is to go through the lecture. Do go through the lecture again. Thank you. Okay, welcome. Right. Do go through the lecture again. Try and understand these terms more, because once you go through these terms, you tend to think that okay, you have got these. But afterwards, when you again go through these terms after maybe 2 or 3 or 4 weeks, then you would probably say, what was that? Right. So do go through these terms again. Read from some good book, as I have already given you 2 3 very good books on epidemiology and public health. And you can ask me questions anytime as well. Okay, until next time, Allah Hafiz.